Hey, hi everyone. Welcome back to the channel. This is Vamsi Reddy, and this is data science project list sixth project, I think so. So today project is credit card fraud detection. So this is a simple project. By using the machine learning algorithms, we can build a model on this credit card detection problems. Okay, let's move into that. And here the data set link. You can clearly get the data set, and by clicking this, let's move into the kaggle.com, and you can find this dataset, and simply you can download here from here. Okay, and I'm importing the relative packages which is necessary for this project, like import OS, import warnings, numpy, pandas, and some more things like MATLAB, C bond, some of the model building things like KNES enable and XGBoost, SVM, some of the things which are necessary for the system, which are necessary for the projects, for this case of project. Okay, and next, we read the data from the local drive. Data equals to pd dot read csv. I am passing the path of my local drive, and let's data dot head equals to, this is the data dot head which you have seen here. There is a top 10 rows from the data set it have contained. And the next, data.tile, it shows that last 10 rows from the data set which we have contained. And actually the data of what is the size of the data set. So the data set is, the size of the data set is 28,000, sorry, 2,84,807 rows and 31 columns. It contains 2,84,807 rows and 31 columns. This and I'm now describe what are the things like mean, standard deviation, median, some like 50%, 70%, the maximum value which have contained in the data set. So simply a small step of code, data dot describe. By using this data dot describe, we can find the mean, count, and standard deviation, mean, etc. Some of the things which are contained. So here the value for each and every column, they have contained some of the things, some of the values and minimum values, and which is the powers of e. It contains the powers of e, so it is a big value. So there is a negative values and positive values also, but it is described as a big values. So finding that. So next, for finding that correlation, for finding the correlation between the each and variables, we find the data dot correlation, simple function find data dot correlation. So it shows the correlation between the two functions, like time and time, v1 v1, v2 v2, v3 v3. There is a lot of, it's a big value. Correlation is a very it shows the in e powers of e, it shows the exponential of e, the powers of e. So it is a very big value. There some of the content in negative and some of the content in positive. So okay, and up to now we have done some of the statistical position of some of the portion of the data set. So let's find that is there any null values present in the data set. So for that case, I'm using print data dot is none of any function. By using the any function, if the dataset contain any null values, it shows this true, which column contain is true. If does not have any null value, it shows simply like this false statements. Here the time is false, f1 is false, f2 v1 is false, v2 is false, v3 is false. So by this means there is no null values contained in this data set. So we have another method like data dot is none dot sum. It gives the sum of the all the values which are present in the column, and shows the null values as the output, how much are. So like that we have seen two types of things present in that. And next, determine the number of fraud cases in this dataset. So now we need to determine how many fraud cases are there present in this dataset. So fraud equals to data dot data classes equals to 1, and valid equals to data dot data class equals to 0. It means if the data is fraud, it will shows the 1, it replaces as a 1. If the data is valid, it replaces with a 0. So outer function equals to length of the fraud by length of the valid. So it will divide it how many things like so how many frauds and the validates. So print the outer function and fraud cases and valid transaction. So for the output we get fraud cases is 492. We have a fraud cases of 492 from this data set, and valid transaction is 2,84,315. So quite it is a lot of differences between the fraud cases and valid transactions. So we can easily find this there is a less fraud transaction 492 only. So we need to describe we need to build a model, and we need to overcome and detect the fraud cases. So next printing the fraud fraud transactions, like what is a count, mean and minimum, like that. So count is we have known count of 492, and mean is 122, and standard deviation 256, minimum 0, maximum uh, 2125, and 70% 105, and 50% 9, 25% 1. So this is some of the described details from the fraud transaction. And valid transaction also, some of the described details we have, like count is 2,84,315, and mean is 88, and standard deviation is 250, minimum 0, maximum 25,691.160000. This is some of the described values which we have content, which we have get from the rally transaction. So up to now we have completed some of the statistical analysis for our data set, like we had go through the head style, and finding the null values, is there any null values, and finding the describes correlation function, everything. Some of the basic things we have covered from the analysis of the data. Let's move one simple thing. EDA, let's explore the data set. So I'm using the correlation matrix. Here clomat equals to data dot correlation, and figure equals to plot the figure of size 12 into 9. 12 is to 9, x-axis is 12 and x-axis is 9, and sns dot heat map correlation map v is equals to 0.8 square equals to true, and show the plot. This is exactly plot which we have get from this output. So it is some of the seeing, like seeing, it is a very measured things, so we can't easily understand, because it is a contain the huge amount of data. So better to go different type of plots and different type of graphs, we for clear understand. For this video I am not doing such a long terms, and just only one of this correlation matrix only I have visualized for you. And next we need to divide the independent and dependent variables, like x equals to data dot drop classes x equals to 1 into the values, how many values are present, and y equals to data classes dot values. So I'm separating the x and y variables and printing the x value and printing the y value. We get the x is in an array format, and y is in an array format. And now splitting the data into test and sets, like x train, y train, x test, y test, and I'm pausing the test data is equals to 0.25, and random state is 55 15. So after the executing this, we have get x train, y train, and x test, y test, some of the components present. That's that are the things we have get about that. So we have build that independent variable, dependent variables, and text and right. And now it's time to build the model by using the super vector mission. I'm using the svm for building the model for this type of for this project. So from sklearn.svm import, I'm importing linear svc, linear svr, svc, and svr. So these are all contained in the svm matrix. So we can analyze this is a by using this default value svm equals to svc, and svm dot fit xtrain and ytrain, and svm predict svm dot x test. So I'm predicting the value from the x test, and we can execute that and we can get a clear understanding. So after that I'm finding the accuracy, precision, and recall f1 score by using this type of code. And simply we can say that from sklearn and matrix importing the classification report accuracy, and some precision score, recall score, f1 score, some of things confusion, everything we have importing from the sklearn matrices, and finding this outline error out, if this outline is the length of the plot is equal to length, then it can present how many length of outliers is present, like that accuracy for test data and predicting some SVM prediction, like precision, recall, and F1 score are then. So we have get the model of random forest classification. Sorry, it shows that we use the random forest classification. It's showing that using the random forest classification. Sorry, by mistake is I did not wrote this thing here. Okay, it's not a random forest classification. It is a SVM. Okay, and the accuracy is 0.99. The accuracy is 0.9. It is well done by the SVM, and the precision is 0, recall is 0, F1 is also a 0. And let's execute the some of the execute the confusion matrix in a graphical method, like here, and we get 71,069 of things are normal. So we have 79,000 we have get normal fraud transaction is 133. So initially we have 492 fraud transactions, but finally we get the fraud transaction as 133. So this model is well perfected well on this billing of fraud transaction, credit card fraud transaction. So it is reduced its count from 492 to 133. Well done, this SVM model is worked well. And this all about this project. You have check out this project. I have provided this a link of this source code file in the description, and I have uploaded in the GitHub also. Please go and download that and try to practice yourself. At the time you can clearly understand where the mistakes are going on, where the things are going on. So these are all about this project. If you like this project, please like, share, and subscribe for more update. And